Hi, good afternoon. I'm Lenandlar Singh. I'm from the University of Guyana, and in this presentation, I'm basically going to present some ideas from my own background check on open hardware, especially drawing parallels with what we know about open source software. So I'm kind of trying to look at whether there are similarities, whether there are things that might be different in terms of principles, in terms of limitations, and so on. So I'm going to talk a little bit about open source software and open source hardware, and where possible draw some parallels. I'm going to start off by talking about openness a little bit, just briefly, and then get into a little bit of the open source software, open source hardware. Examine maybe some opportunities and challenges locally, and maybe in similar context. And then I'll just, for information's sake, share a few interesting open source hardware projects that I myself didn't know about, but just found after preparing for this, or while preparing for this presentation. And then maybe what we can do locally. I'm not sure what we can do. Well, openness is a key idea nowadays. It seems like almost everything we talk about seems to have an open element to it. It's probably fair to say that most of this openness has its roots in a major way in free and open source software. Nowadays, you'd hear openness in education, for example, as a big thing. Open educational resources. And massive open online courses. In government, you'd hear about open data, open government, as they relate to things like e-democracy and so on. And really, for me, this is another addition to my own understanding of this open movement. So why openness? I think the open hardware idea seemed to be, even though very similar to the ideas seem to be very similar to the other open ideas. Open hardware is, in my view at this time, maybe from my limited understanding, slightly different. And I think it has to do with the artifacts themselves. If you look at the other things, most of it is digital. Whereas with open hardware, even though designs and so on are digital, there is that physical element, the actual hardware itself, and I'll talk about that a little bit. So I found this nice thing here about open hardware is like open software, so I thought I should start with that. And what this really is talking about are the artifacts that Vidya would have mentioned. Documents, whether they're software that the hardware works with, design issues, design tools, maybe actual software that is used to build the hardware itself or set up the hardware itself. So that is one set. And then the idea about, so when we think about open hardware, we think about those things, the design aspect of it. But in my mind, I'm still thinking also about the actual physical representation. Because what I'm trying to do here is draw some parallels with open source software. And I'll come back to that in a little bit. So the question for me really, as I'm thinking about this, is open hardware really like open software? For me, that's the question, or a question that I need to explore further. There are a number of, if we may, foundations upon which this open hardware movement is driven, and I find this one by Graham Seaman quite interesting. Fairly straightforward. There are three things that he mentioned here. He talks about the interface of the hardware. It must be explicitly made public. So, for example, if you say a piece of hardware is open, and that hardware connects to other components, we need to know how to get the two components to work, and therefore we need to know how your hardware works. What is the interface? Can we program our hardware to communicate with your hardware? So that's sort of like the first tenet, according to Seaman. the design also must be made public so that others can implement it and learn from it and so on. And I'm supposing here this means the physical design maybe as document artifacts, documentation, and the other things. And then there's an interesting one, the third one, because even though the second set of things might be available, can you really replicate it easily? Can you do it if you don't have the tools to do it? So here is a design, here is it, but can you actually go and make it? And I thought that was very interesting. So he said, really, if you're suggesting that hardware is truly open, it should satisfy those following requirements. So that's very interesting. Now,
so just to admit, Len, on a point of that, so what we're saying is that if you use CAD to make a drawing,
yes.
So making that drawing available is not enough. The CAD software that you use to make a drawing must also be free and open
source.
What
he's suggesting is exactly that. Because
so you can't have that CAD file in a proprietary form.
I suppose that is an interesting thing.
Which is very interesting.
Yeah, that's very interesting.
Because one of the I think it's called the Open Design Alliance. That's exactly what they do. They're actually working on the CAD software.
Yeah.
As well.
Yeah.
So yeah.
Because if you think about it, I mean, a design for any fairly sophisticated product would be complex.
Right.
And therefore, how do you replicate it? How do you improve on it? How do you play around with it? So I think that's very interesting. Again, I'm zooming back into my comparison, and that is the first thing I thought about. Well, how is open source software? How is open source hardware similar to open source software? And in this slide here, I'm trying to play around with some ideas in my head. So the first one I thought about sharing. Now we can share the open source hardware artifacts like the design and so on. And if you think about one obvious thing, you're not sharing hardware, are you? I mean, the physical artifact would, I don't know, you can't make that you can make it and share it out for free as per se. But there's a difference there, a difference between the actual hardware itself and the design for it and all the other things. Whereas with open source software, really everything is the same thing, isn't it? The design, the software is the design in many cases, and therefore we can give a copy and still have it. Right. So you can replicate that. And I think in my mind, when I thought about one similarity or one difference, I'm thinking about that. But I'm also conscious that the idea of open hardware is not necessarily to distribute the product for free or make it available for people for free. But it's the process, the documents, and all of that. What it means though is that if you're going to talk about these two things, I suppose the barrier to open source hardware, if there is a barrier, it's probably a bit higher than that for open source software, because of the ease in which you can replicate and try things out and all of that. If you're at a company, so that's at the individual level. If you think about a company who can actually make the things, that's not a problem if they have the design, maybe. And then there is the costing and so on. So for me, that's something that's going on in my mind, and I think it's very interesting. And I thought about the design as well, and this one is interesting for me too. When you look at software, open source software, documentation is always a cry out for people. But you guys didn't document this. You just have the thing working really well. So that's one thing. So the thing might work really well, but if you want to add something to it, you got to go and study it a little bit. And that is sort of like, I don't want to say the opposite, but it's kind of different for open hardware, where the focus seems to be on let's get the design. You got to get the design. It has to be clear. It has to be maybe represented in so they're sort of like, I wouldn't say they're the opposite ends really. Maybe it's just how the communities are, but because of the physical nature of the artifact itself in hardware, you probably are going to need those documentation and upfront to build them. Whereas as a programmer, you can just sit down and hack away and do all of that. So design isn't a big thing really. Design documents and design artifacts in the software, in open source software. I mean, generally. Whereas in the hardware, it seems like that seemed to be the thing that you want to share, and that's the priority thing really. So when I started, I mean, this is very much an academic kind of discussion really, but I thought in terms of when I examined the two things, that's something that's interesting. And then of course the cost, because if you're going to really make physical artifacts, physical chips and circuitry and all that, that's different from burning a CD and sharing around software. Yeah. So just some things to think about. And interestingly, the licensing, because it seems as though hardware has more patent kind things attached to it, whereas with software, it's more intellectual property in the form of copyrights and so on. So if I were giving a first lecture on introduction to open source software, open source hardware, perhaps this is one of the pointers that you might want to think about. Patents, and it runs a bit deeper than that, because I think the way patenting works is a bit slightly different from copyrights. But you can get into that if you wish. And in terms of open source hardware, when we talk about open source software, we talk computing generally, whether it's a phone or a laptop or whatever. When you talk open source hardware, probably not always going to be, it could be anything. Open source hardware could be anything, couldn't it? Could be hardware for a tractor.
Could be, yeah.
That has nothing to do with computing.
Yeah. The definition does include things which are other. Yeah. Kind of got cars and so in the list of projects.
Yeah, in the list of cars and that kind of thing. So if I were to give you one slide for what I started looking at, it's this on here. And I think, like I said, for a beginner like me, this is an interesting starting point. So starting from where to moving into it. And then I found this was you couldn't talk open and not talk Stallman. And he made a point 14 years ago in 1999, but it was an interesting point. I don't know whether the open hardware movement was anywhere really around yet. He said, I see no social imperative for free hardware designs like the imperative for free software. Freedom to copy software is an important right because it is easy now. Any computer user can do it. Freedom to copy hardware is not as important because copying hardware is hard to do. And that's an end user perspective. Right. Perhaps limited, but it makes one point. There's some difference in terms of what you can do as an end user with open hardware. Maybe a bit more challenging than open source software. For a big company, not so much of a problem, because if they got people working for them, they got money to invest, they got business to make. Mm-hmm. That is one difference I also see between the two movements, the open source. So while in principle and in spirit, it's openness and about sharing and so on, there is a limitation of what you can share. With the hardware and the software. So that's interesting. And then if you get down to the licenses, which I'm not going to talk about, I just extracted this from the march30.org, mash30.org seems to be an interesting place for some reading. It talks about different kinds of licensing that's evolving. So you have the share-alike style from like the CERN Open Hardware license, and the TAPR, Tucson something. They manufacture radio-based things, and then you have the attribution style. So there seem to be some different directions in terms of that. And of course there are going to be issues, like for example in the TAPR, Eric Raymond, a famous open source guy, talks about issues with the TAPR, for example. The license has lots of problems and it strips the word distribution of its normal meaning, assuring lots of contention over edge issues. Also concerns that open hardware license may merely place the design and or idea into the public domain by effectively publishing it before securing the benefits of patent protection. So there's still that tension between, protection before you publish the thing and that kind of thing. I mean, I can't speak further on this, but it just points to somebody looking at potential issue in some of their licensing. There are other licenses. This is just one. So it's just sort of like a point of reference. Just a little bit quickly about maybe what it might mean for developing countries. I don't know. I really don't know. I mean, this is all new to me. But because really, again, drawing parallels with open source software, we can take Ubuntu and put it on a laptop and say, try this out. That's very easy to do. And you can learn Ubuntu in a week or whatever and so on. But what about your startup and the knowledge transfer for open hardware? I mean, I'm guessing it's going to be a bit more challenging to look at. Okay, here is a design. Here is a problem we have locally. It might need a bit more skill. Unlike, say, we have licensing problem with Windows. Well, let's just show them away and bring Ubuntu, and over the week we can replace all of that in the office. Whereas with hardware, so while there's a potential for knowledge transfer, there's that issue as well. If you can do that, then perhaps cost. I don't know. I've seen some interesting projects where that can be done. Theoretically, it could encourage innovation. I'm thinking here maybe you don't need to. If there is an open hardware, you can buy it. So you can buy the product, like what Roger showed us. You don't need to. Maybe at some level you don't need to understand the design. You just have the product and maybe the interface to it. That might be enough for you to start innovating, plugging that in with the other and solve some problems locally. So there are going to be layers at which you can do innovation. And it's just like the open source software, I suppose, similar in this way that if you're going to add to Linux, then you got to be good to understand Linux. But maybe you can write software that runs on a Linux box, and that's a different layer, probably less difficulty to deal with. So there are different layers, really. So innovation can happen. Maybe you can redesign the whole thing, or do what Hennessy and Raymond and Rob, the other guy, did, or you can just add on to it. So I think there's that opportunity. And with that comes the range of users, end users, marketers, product developers. I think really for me at this point, at least based on what I understand, the end user is probably the group that's not necessarily going to be the pushers here. What I mean by that, you can take 6 million people and drop Ubuntu on their desktop. You're not going to get those 6 million people to start building hardware or using hardware, studying open hardware.
No, hold on. Sorry.
Yeah.
Okay. So now let's just think this carefully. It's saying to the end user is that, hey, the end user has this lighting device. 6 million of us have this lighting device in a place with low energy, and we would like this light to be done in such a way that it is more cost effective. That because where we are, the light is heavy, it pulls down from our roof or whatever. Because our houses are shanty towns. So why is it that you have to have this particular thing? So therefore, it takes that feedback. Of course, you need the skill of a design engineer, like you would need a software programmer. But it takes what it says is that you're not relying on the company that produced the light to make the changes. You're saying to anybody else, look, this is how the light was done. If you want to replace X component with something that is here locally, this is where you'd have to stick it in. So that is what the end user idea is. So therefore, in this part of the world, so the company doesn't have to make a light for that part of the world, right? Is that they can make their own light, which fits them.
No, that is absolutely true what you've said. But that is looking at the end user from one direction, which is fine.
Right.
How can we solve the energy consumption problem, for example, for 6 million people?
Right.
Open hardware design. We can look at that. In terms of the contribution, to developing the community. So if
we're not focusing on developing the community, you're developing the what you're doing is you're saying, because at the end of the day, the product is a better human lives, right?
Yeah. No,
so the human lives will be
what
better.
You're saying. I'm
so
just
they're involved, and you're not involved, and you can rapidly change that design. It's not the inventor, the patent owner who's going to drive how that is. Of course, if you're responding to market forces. So rather than say that because we can't sell this light in X, we're withdrawing from the market because it's not profitable, it says, okay, no, but you guys can take it and make something else with it, and of course you get it back with the money. So to me, that's what I see. And the end user feedback, or it's at a different level from a customer service representative. We would like a green thing, but then the company says, no, the green paint is too expensive.
That's a very practical way to look at it. I was just thinking about.
But let's look at our tapirs. Sorry, I used to think of the tapir. Remember the company that made the tapir is gone out of business.
Yeah, that's right.
Right?
Yeah, that's interesting.
And it's the end users, it's the drivers and the mechanics and whatever. These are the guys who are using the tapir to make it. They're the ones who are deciding what to do.
I think you're right, because from the hardware perspective, that's where the end user value really differs
from the manufacturer.
So that's interesting. That's a very interesting. Well, I suppose for us locally, I don't know. These might still be very theoretical things. There's one like the supply-demand thing. Really, I mean, for this kind of thing, might push its development. The one that interested me really, like we know, for example, maybe in societies where, and that's true also for the open source thing, where we are consumers largely in this kind of environment. We don't even develop for the platforms themselves. So I don't know how that is working in the open hardware industry, how it's driven, if there is a kind of force happening. Maybe locally that might be a challenge. But the thing that interested me, and I'm going to get to this one here. This one is very interesting. So it looks like on the right there is an old computer, a laptop. It looks like a laptop, and maybe something is wrong with it. And usually, what happens when something is wrong with it? If something is wrong with one part of it,
you have to dump the whole.
You dump the whole thing. Suggesting maybe that if these things are more open, then we can just plug in and plug out, and therefore maybe you can replace that thing, or if it doesn't work, you can still take the memory and take the other things. And
let's look at our top here. Let's look at the top here. Because you can take the thing, I'm not saying that was open design. But it's the whole idea that you recycle.
So for us,
you need to know the design so you can recycle.
Yeah, that's right. I think for us here, and this is Ghana, for example, that picture there, and that's similar to Ghana. I'm sure we dump a lot of that. I don't know what happens in the developed world if it's cheaper to dump than to extract those bits and pieces.
They do metal extraction. It's material extraction.
Material extraction, and then, but that's an interesting proposition, I think, in terms of what potential for open hardware might help to reduce some of the good things, save us from some of the good things we throw away. Because, all right, so this is just kind of like if I were telling students about this. This is a 1977 picture of Apple II from the Apple user manual, and it really is showing a design. And then, so around the 70s, you had a lot of things going on.
It's like the old time car manuals.
Yeah.
They used to show the engine.
Yeah. Like we used to have I can't remember, we always had a spray can that you spray for pesticide with and so on. And we used to, in a manual, we used to strip it down and do all that kind of stuff. We couldn't make one ourselves. I don't know if they still do that. But what really happened is that we moved, you got less than, so now what you really have is this. And I don't know what you get in your user manual now. It's certainly not that, but it has moved, and it's getting actually. It's physically that like the iPhone, for example. if something goes wrong, then somebody's probably got to turn the screws to open it. So that's certainly happening in the business world. Again, for me, that was interesting, and I think if we look at the history, then it might be clear, why the design became less and less. So just some slides I took from another presentation, which I thought might be interesting, so I'll go through them quickly before I end off. Like this circuit, the Arduino, is that how you pronounce it? Apparently you can plug in and plug out easily with this and program it and stuff like that to do different things. If you're into gaming, then there's a plug-in, plug-out console that you can actually check out. I didn't know that they had this open source satellite initiative. That's a hardware thing. Apparently the military drone, I just took the slide, so I should have gone and checked whether this is true, but but it seems like those designs are. And the question I was asking Roger is exactly this. Can you really hide it? So if I buy this car, what might prevent me from replicating it is maybe patent things and licensing and all of that. But really I can actually use a lot. I have access to a lot of the design itself with physical products. So that seemed to be. I didn't know that myself, that there is an open source, open smartphone that you can actually play around with. And then there's a OpenBTS, which is some GSM. So that's a spectrum of things. A prosthetic fishing rod. That's an interesting one. So that's available. And there's a drug discovery thing. And this slide here, this is interesting. This is showing number of projects up to about 2011. I couldn't find the 2012 one. But it's clear that there is some movement going on with a number of open hardware projects around the world, really. And it seemed to be growing fairly rapidly. So I'm sure there is more than that, but you have about 300 maybe known open hardware projects.
Steep increase from 2009.
From 2009 to 10, double,
3 times. From in the last 3 to 5 years, about 3 times it.
I wonder if that was the economic crash.
I'm not sure what kind of effect.
Yeah, and all the engineers went out to work.
It would be interesting to see how that is affecting other things.
You say, it being got nothing to do, let's go work on collaborate on something.
So that's very interesting, I think, in terms of what's happening in the. Maybe it's suggesting that we should pay more attention to this here. And what you can probably do yourself, maybe run down to one of the stores and buy a few things that you can easily plug in and get something going, if you know how this one works with that one and that kind of thing. I suppose it's sort of like installing Linux on your box, and then you say, well, what software can I run OpenOffice or LibreOffice? And you put together an office. And also
system. Getting the distribution of Linux for the kind of box you have.
And for the kind of box you have.
Not everybody got to say.
So I suppose this is looking forward, to the kinds of problems it can solve. And this I don't know about the White Rabbit server. What it's saying to me though is that it seems like big organizations. I mean, CERN is famous for the web, right? That's one of the big, Tim Berners-Lee and all that kind of thing. So they have that kind of tradition. But it seems like there is something about big companies that's doing this. So in conclusion, really, for me, open design. Telling people how things work. Maybe the end user might not be interested. Just get the light working better for me. Let the tech guys see how the current lights are working and all of that. And then, of course, improving, reducing cost, maybe making the world better. So what can we do? I don't know. Software Freedom Day, we always say, what you can do at least one thing: install Ubuntu or try LibreOffice. I don't know what we can do. Roger suggested something very interesting. You can write some things, burn it onto that, and plug it into something else and see what happens. Should we care? I think so. I feel excited about this. this whole thing. Because when you think about hardware, really, we don't assemble, do we? You go downtown and you buy something and you plug it in and that's it. You don't think about, well, I can make this setup myself. So you might want to put in some heating or something at home. And then you might buy the circuitry, you might buy that. I don't know how, I'm just guessing here. And what is it for us? I suppose things that work better, things that are cheaper. But that is something we have to think about. How do we move this from, this kind of discussion to, so there is something we can play around with. So yeah, thank you.